Conjunction, junction, what's a function? Today we're going to learn about relations and functions. A relation is a set of coordinates written as xy. As you can see, you have a set of ordered pairs here. You've got -3, 7, 0, 9, 2, 15, and 9, 2. Each has an x value and a y value. We are going to put each of these values, so we're going to put the x values in its own set, which is called the inputs, also known as the domain. And then we'll take our y values and put them into this other set, which is known as our outputs, or the range. There are 4 different ways that you can write a relation. You can list them as ordered pairs, which is what we just saw. They can be shown in a mapping formation, looks like this, or a table of values, or you can show it also as a graph. We're going to talk about each one of these in a little bit. Okay, function. It's a specific type of relation that relates one set to another. A set of ordered pairs where the x coordinate is matched to one and only one y coordinate. You can determine relations or functions by the same 4 methods: order pairs, mapping, table of contents, and graphs. There's kind of a trick to picking out functions. It's actually to pay attention to your y coordinates. If all of the y coordinates are different, then it is a function. If any of the y coordinates repeat, then it is not a function. So I'll show you what I mean by this. All right, we're going to pull this train into the station. We've got 3 different boxcars here. So looking at each set of ordered pairs, let's go ahead and determine whether this is a function or not a function. I'm going to write F for function and NF for not a function. Okay, so looking at the green car, let's look at their ordered pairs. Now remember, the only thing we need to look at are our x coordinates. So that's 3 and 4. So all of our x coordinates are different, so therefore this is considered a function. Now let's go on to the log car here. So we've got, again, we're only going to look at our x coordinates, so a -4, 0, and 2. If you notice, all the y values are 0. They can match. It is okay. The only thing that cannot repeat are your x values. So since -4, 0, and 2 are all different, this is also a function. Now let's look at the caboose. So let's look at their x value. So I've got a -1, -1, and 2. Well, if you see this -1 and this -1, they repeat. So since they repeat, it is not a function. Remember, the x values are the only things that cannot repeat. All right, now let's talk about a mapping situation. Again, we also want to pay attention to these x values. If an element in the domain is mapped more than once to one element in the range, the situation is not a function. Your x values, again, cannot repeat. So we are going to write 2 different sets. Again, we've got our domain and our range. So in our domain, I am putting my x values. So I want my x values in here and my y values in my range. So what x values am I going to put in? Now we must list these in consecutive order, meaning smallest to biggest. So when I'm looking at my x values, we're going to consider 3, -5, 10, and -4. What's my smallest x value? Looking at a number line, the one that would be the smallest would be the -5 here. And then we would have a -4, and then 3, and then 10. So we've listed those here. Now we're going to write our range, our y values, also in that same consecutive order. So looking at my y values, I have a -5, -6, 3, and 0. So the smallest is -6, then -5, 0, and 3. In order to create the mapping, what we're going to do is map each coordinate to itself. So there's one coordinate. So the 3 and the -5 are together. So I'm going to go and find my x value of 3 and map it to my y value of -5. Then I'm going to look at my second coordinates, -5, -6. So I'm taking my x value of -5 and mapping it to my y value of -6. We're going to continue on. So 10 is going to map to the 3. And I have a -4 to the 0. You can see this is a function because none of my x values repeat. Okay, now let's check your understanding. So determine if each mapping is a function or is not a function. Let's look at the first one here, giving you a domain and a range. And as you can see, we've got the coordinates 1, -5, 2, 3, and 3, 9. Since these have separate arrows going to, like the arrows are not going from any one of the x values. Remember, the x values are the only ones that can't repeat. So therefore, this is a function. All right, let's look at one more. Two more, actually. So in here, we've got the domain and the range. So you can see I've got -1 maps to a -4. 5 is mapping to a -1, and 5 is also mapping to a a +8. So if we were to write this out, I would have the coordinates 5, -1, and 5, 8. Well, as you can see, our x values of 5 here are repeating. So therefore, this is not a function. Okay, so here's one last one. Go ahead and pause the video and determine whether you believe this to be a function or not a function. Okay, welcome back. Hopefully you found that this is not Actually, is not correct. This is a function, just trying to trick you. So you can see I have a -3 to -2, 2 to 6, and 5 to 6. My x values are the only ones that we care about, and not one of them repeats. So therefore, this is a function. Hopefully you got that right. All right, now let's look at how a table of values. So again, we're going to keep paying attention to our x values. They cannot repeat. So if an x coordinate repeats, it is not a function. So let's look at our first table. We have our x values of -1 to -8, 2, 3, 6, 7, and 8, 10. Really, again, I'm looking at my x values. Do I have any repeating x values here? Not one of them repeats, so therefore this is a function. All right, let's look at another one. What about this one? Is this a function or not a function? Now, I've got 2 8s over here that are repeating in the y values, but the y values don't matter. Remember, we're only talking about our x coordinates. Do I have any of my x coordinates repeat? So these are all different, so therefore it is a function. Pause the video and tell me whether you think this is a function or not a function. Okay, welcome back. So what did you pick? This is a function or not a function? Well, again, we're going to look at our x values. So let's look here. You notice we've got -2 being repeated. So since it's a repeat, this is not a function. Hopefully that's the one that you chose. All right, what does this look like in a graphing situation? We're still looking at the x values. However, in a graphing situation, we're going to kind of look at this in a little different way because it's called the vertical line test. The vertical line, if this line touches or passes through more than one point on a graph, then it's not a function. So here's what I mean by that. Let's look at this first graph here. I'm going to pull this vertical line across this graph. And if this line hits any one of these points in more than one place, so does it hit 2 points at the same time, then it is not a function. But if you can see, it only hit 1 point at a time. So this first one would be considered a function. Now let's look at our second example here. So for the second example, I'm going to pull this through. You can see it hits this point and point only. this point and that 1 point only. But here it's hitting 2 points at the same time. Well, if we look at the coordinates on this, this coordinate would be what, a negative 2, 2 and a negative 2, 5. So our x values are repeating. But on the graph, it's so much easier just to see if a vertical line touches in more than one place. So therefore, this is not a function. All right, let's test this one out. So use the vertical line test to determine if the following graphs are functions or not functions. Here's our first graph. I'm going to pull this line across. Is it touching that graph in more than one place? Is it hitting 2 points at the same time? It does not. Nowhere along there does it hit it in more than one place. So this is a function. All right, let's get a different graph. What about this one? It's a little different shape. It's kind of the V shape. This is actually the graph of the absolute value. So let's see, is this graph a function? Well, when I pull my vertical line, am I touching this graph in 2 places ever? Not at all. So it's only hitting in 1 point no matter where I'm at on the graph. So therefore, this would be a function. Last graph. Go ahead and talk about this one. Is this a function or not a function? Okay, well, let's pull this vertical line across it. You can see I'm only hitting this 1 point right here, but any place else on this graph, I hit in more than one place. So here, I'm hitting the graph here as well as here, and that kind of continues throughout the whole rest of it. But it's because I'm hitting in 2 places, this is not a function. Okay, well, go ahead and work on the assignment, and hopefully this makes sense to you. If not, go ahead and go into some tutorials or ask a neighbor.